Hello friends, I am Sumit and today I will continue the DSA series. Our topic for today is binary search. So this is also problem number 704 on Leetcode. So we have already learned linear search. In that we went to index by index and search for our target and then we have returned our index value. Okay. So in binary search, first we have a prerequisite that our array must be sorted. So we will apply binary search on only on sorted array. Next we will see how we can approach our problem. So this is our array. So it is our mid value. So if our array is sorted, then if let's say this is our target value. So if our array is sorted, and if we find our mid value, and if the target value is greater than our mid value, then it must lies on the right side. So, and if our target value is less than our middle value, then it must lies on the left side. Okay. Then this is the only approach we will apply. We will find the middle index of our array and then we will compare if our middle index is only the target, if our middle value is the target, that is nums of middle value is the target, then we will simply return our middle value. Middle is our index, and if our nums of middle value is greater than the target. That means our our middle value is greater than our target value. Then we will search on the left side. So we will just take two pointers, start and it will be the mid. So now we have only search to the left of the array. So we will update our end to here, which is mid minus one value. So we will date our end as mid minus one as well. Else if and at last case our target is greater than the our middle value. So we have to search on the right hand side and here we are searching for the left. So in this case we will update our start value to here and we will search on the this part. Okay. This start will be our mid plus one mid. So this is our approach for the problem and now we will write the pseudocode for this. Binary search. We will take the vector in nums and our return type will be integer as we are returning the index at which we find our target and also we have to take the target value. So we will take the target which is again of integer type. Now we will initialize our start to 0 and our end will be nums dot size minus 1th. value. Actually, we are taking this like I take an index 0, 3, 5, 9, and 12. So we are taking start here and end here. Okay, and we will apply a loop that our start must be less than equal to end, so that our when our start and end point to the uh, same value, our that's our middle value only, then we will return that. And if our start is greater than the end, we will come out from the loop. So we will find mid value here. Our mid equal to start plus end minus start by 2. I will tell that while we are using this formula in a while. So then we will check if our target value is equal to our mid nums of mid. If it will return true, then we will return our mid, which is the index value. Then uh, our mid value, and else if our target value is greater than nums of mid, that is if our target value, let's say it's 9, then if our target value is greater than our mid value, then we will update our start here. Start equal to mid plus 1. So we will update our start equal to mid plus 1. So, and last case, that if our here we are searching for the right side, and here we are searching for left side. So if our target is less than the middle value, let's say if our target is 0, then it is less than the middle element. So we will search on the left side, and our end value will be updated to here, which is mid minus 1. I will write here mid minus 1. So here we will update our end value as mid minus 1. And if we find, if here we will find our index value. So if we don't find our index here, so it is not in the loop. So we will return minus 1 in that case. And now we will see why we are using the formula mid equal to start plus end minus start by 2. Let's say our start value and end value is as much as greater than our end. So it got overflow when we will add that. So we are using this formula, and this is the same formula actually. We will solve it. So it will get 2 into start plus and minus start by 2, and then it is start plus end by 2. So this is the same formula as we have seen to find our mid. So now we are dry run. We will go into dry run one this code only, this array only, so we can understand more better how it works. So 1, 2, 3, 4, 5. We will take one start, which is here. We will take an end here. We will take end here, and our middle value will be here as 0 plus 5 by 2 in integer. We get 2 only. So our middle value will be here, and we will search for the our target, that is 9. So first we will see if our target value is equal to our nums of mid value. So 3 is not equal to 9. So we will move forward, and as 9 is greater than our middle, so we will search for it on the right side. So we will search for it on the right side, and we will update our start value to the mid plus 1, which is here. I will make a separate array now for that. 5, 9, and 12, and our start gets here and end here, and we will find mid again, and now our mid will be pointing here. So again we will check if our middle value, if our nums of middle value is equal to our target. Here it does that, it 9 is equal to 9, so we will return the index at the middle value. So here our index is 4, so we will return 4 for the answer from here only. Now we will see our time complexity. Time complexity. What we are doing is we are dividing the our array in two parts. Every time we iterate in the loop, that if our initially our array is of n size, then in the second iteration it will be of n by 2 size, as we are only searching on either on the left side or on the right side. So and after that, or on next time, it will be getting 2 to the power 2, and then again it will be n will be equal to 1, that when it gets divided and divided and divided and it becomes 1, so our n by 2k value will become 1 at both case. So n equals 2k, and then we will take log, our value gets log n equals k. So for k operations, we will get our time complexity. We go of log n from here, and which is the worst case complexity. And as we are not storing anything, we are just returning our index value. Our space complexity will be of O of 1. So now we will see how we can code this. We'll write the code here. First we will take the start equals 0, and end equals dot size minus 1, and we will take a value that will run until our start is less than equal to end, and first we will find our mid. mid equals start plus and minus start divided by 2. Now we can check if our target value is equals to uh, our nums of mid. Then we will return our mid value. Here I have changed the parameter. You can change here and else if our target value is greater than our nums of mid. So we have to search on the right side. So we will update our start to mid plus 1 and else as we are going to search on the left hand side. So we will update our end value to mid minus 1. And if we can't find our index on the array, then we will return our minus 1 in that case. So this is the code. We will run it. I have already solved it, so it is showing. So it's been submitted. So if you have learned something from this video, do like and thank you for watching this video.